good. Let's look at number 3 here. It says this table represents a linear function. What is the slope of the function here? So let me just copy out this table here. X and Y, 1, 5, 2, 9, 3, 13, 4, and 17 here. So if you look how we calculate the slope of the function here, we can simply just take our first differences, right? So what does that mean by first? What do I mean by when I say first differences? Well, I'm basically going to look at 2 points of the graph. So look at these 2 points here, and I'm going to subtract the second term from the first term. So in this case, I know that my x's are increasing by 1, so I don't have to worry about my x's. These are my independent variables. So I'm not really concerned with these ones. As long as they're increasing linearly, it's fine. But what I have here, my y here, it says here, the table represents a linear function. So we already know it's linear, which is great. So how much is it increasing by? So 5 and 9, so I'm doing 9 minus 5 here is positive 4. 13 minus 9 is positive 4. And 17 minus 13 is positive 4, right? Therefore, my first differences here are positive 4, which means this proves that this is linear, but it also proves my slope. My slope here is 4. It's increasing by 4 every single time. If I were to graph this function, what I could do is I could take all these points and throw it onto a graph, right? So if I sketch out this graph for you here, I have 1, 2, 3, and 4. So I have 1, 5. So let me put 5 here. 1 and 5 would be this point. 9 would be here maybe. And then 13 would be here. And then 17 might be like here or something like that. If it extends all the way here, there, and we get something like this. So this here would be my graph here. And if you look at how to calculate my slope using my graph, I can simply just say it's rise over run, right? Or I could simply just use the equation here, m equals y2 minus y1 or over x2 minus y1. So y2 minus y1 over x2 minus x1. This here, if I were to take out these 2 points, for example, so this is point 1 and point 2, I could simply just do y2 here is 9, y1 here is 5 over 2 minus 1. This is 4 over 1, which equals 4. So it doesn't matter which way you use it. You can solve it through the equation with the slope. You can solve it through first differences. Or what you can do is I can actually show you graphically what's happening, right? As you can see, I'm at 0 here. I'm moving up by or if I take these 2 points, let's just do these 2 points here. I'm moving up by 4 and up by 4 here, up by 4, and then left, right by 1, right? So rise over 1, run. The rise is 4, the run is 1, which equals 4 divided by 1, which equals 4, right? So either way, this graphically, solve it through graphically, solve it algebraically, or you can solve it for the first differences. It doesn't matter. This graph will give you a slope of 4 here. So so in this case they did they plot the points here, and they did the slope equation here, m equals y2 minus y1 over x2 minus x1. That's great. And they chose 2 points, and they calculated the slope, which equals 4. So great solution and analysis. So the solution here is correct as well.